In this video, I would like to introduce how we can connect HBM MGCplus instrument with ARTeMIS Modal. I have a unit of this instrument here on my table here, and on top of this I have this steel plate here where I have connected a single B&K accelerometer that is then put into one of the channels on the back side of the instrument here. The unit is then connected to my PC using an Ethernet connection. And inside ARTeMIS I have created a very simple project. It's just a geometry that resembles this plate, and there is a single channel inserted where there is a channel fixed to this position here, pointing in this vertical direction here. This is then our B&K accelerometer. This one here should resemble. This is a OMA project designed for operational mode analysis, but it can also be a project that you define for experimental mode analysis, for impact testing. It's exactly the same way that you will have to set up the instrument, the HBM device. So what I'll do in this video here is just to show you it on an OMA project. What we'll do now is we will go to the task where you control the HBM hardware. We go to the data acquisition task here, and here we select HBM. And now we will try to detect the connection to the instrument and what instrument that has been connected to the PC. But in this case here it is unfortunately not possible, because the automatic scan for HBM instruments does not work for the MGCplus instrument. So in this case here we will have to add the connection information manually. So for that reason I will answer yes to this question I get here, and then I get this dialog here that allows me now to add a device like this, and it suggests then by itself the MGCplus instrument type, and it also suggests an IP address and a port number. If some of this is not correct, then you will just add other information here that matches what connection you have with your instrument. The next you have to do is you will have to validate if this information here is okay. And if it lights up now, as you can see here in green, it means that the information provided was okay, and we can actually establish a connection to the instrument from ARTeMIS. I click OK then, and now this task is being set up. We are now trying to set up communication with the instrument. Once this is done, then the next you will be presented with is a list of all the channels that you have in the instrument. And as you can see in this case here, there are a lot of them. I know that the B&K sensor is actually located in this channel 37 here. But before I can start using it, I will have to actually add information into the user sensor database that is stored here on the computer, that allows us to then transfer the voltage that is being measured into engineering units. So what to do, that I will do a one-time operation for this sensor here, and that is to go to the HBM sensors dialog here. Here you have all the templates that are defined in the HBM sensor database, and over here we then have what has been defined by the user based on this. Right now there is nothing here, but I will start by selecting a template for an IEPE sensor, which is the type that this B&K accelerometer is. So I will select this one here, and I will insert it into the user sensor database, and now it's located over here. And if I click on it, I will be able now to edit the information in this these dialogues here, these property dialogues. I can here rename this to something more meaningful, perhaps, like this. And down here I can also add how I would like to scale the output that comes from this particular sensor here, so that it becomes some engineering unit that we would like to have it in. In this case, I will use a so-called 2-point scaling that allows me to set up that 0 voltage will correspond to 0 G in this case here, and then 0.0961 voltage will correspond to 1 G. This information here you can get from the calibration chart that is distributed along with the sensor. I will then update the sensor in my user sensor database with this information here. I do that by clicking this button here, and then I can click OK. This is, as I said, a one-time operation that has to be done a single time in order to populate this user sensor database. Now I can select that I would like to measure acceleration in this channel here. I would like to use some information from the HBM database, and I will then select this BNK accelerometer that I have just defined. That's it. If I had more channels connected with accelerometers in this case here, I would of course have to do more of these, but in this case I only have this single one. I click OK now. And now the task is being initialized and set up for operational mode analysis measurements. And what we can see here now is we get the geometry over here where we can see the single sensor we have defined in the project. And over here we have then it indicated that there is one sensor located or attached to one channel, and this is channel 37. So now we need to pair these two things. The internal channel that was inserted when we defined this project here, this has to be assigned to actually being measured in this channel 37. We simply do that by clicking this auto assign button here. That will then match these two things together, and we can now see it lighting up green here, and we can see that the hardware channel 37 is now linked to channel 1 inside the project. Then what we can do is we can try to add a display that allows us to see the running data when it starts coming. We can also add another diagram that allows us to see the spectral density being calculated on the fly. I have to select then the spectral density diagram down here. It appears here now. There is another diagram here we don't need here. So now we will have something coming up here in frequency domain once we start getting data. The only thing we need now is we need to configure the sampling rate to use. We do that from this option up here, which will open this dialog here where we can now select among all the different options that are available from the instrument. We can now select what sampling rate we would like to use. I choose to use 4800 Hz in this case here, which will allow me to see a reasonable amount of the different modes of this steel plate here. The only thing we need now is otherwise also is to provide what type of filter we will use for the aliasing, anti-aliasing filter. And in this case here I will select the Butterworth filter that cuts off at 1000 Hz, like this. That's it. Then we can click OK here now. And we are actually now ready to start getting data. I simply have to click now the start instrument here, this idle button here, and you can now see how data is actually streaming in to ARTeMIS from the instrument. And if I take my little pen here and then I start tapping here, you can also see how the modes appear in the spectral density diagram to the right. This is the way you set up the connection to the HBM MGCplus instrument. Thank you very much.